God.
Okay, okay.
Okay. So for this week's build, we
Wait,
decided.
before that, before starting with the bill, I think it's important to introduce Nandini today. So first of all, for people who'll be watching this, Nand is our sister-in-law, mine and Gyan's. So she's also getting onboarded. She wants to learn everything about AI, and we've now sort of are going to introduce her to a lot of blockchain things as well, considering the next product that we're going to be building is for the Stellar Hackathon. So this is one way of onboarding her to blockchain as well as to everything that we are going to be doing in this AI space. So Gyan, maybe you can tell us what we're going to do first before we start with the brainstorming.
Yeah, so for this week's live build, we decided to work on like this agentic hackathon since this aligns with the AI subject that we are touching upon. So Stellar has this agentic hackathon, and here are some ideas and inspirations that they've shared. I think in as per our previous discussion, we thought of going for this private x402 payments. But it's also an open innovation hackathon, so we can decide if this doesn't work for us, do we want to do anything else? But for now, we are going to explore this line of thought, which is privacy pool for X402 payments with pre-funding, operator management settlement, and batch facilitator withdrawals for efficiency. So before we go deeper into this, I actually put up some things which people would want to kind of understand, right? One is first, like if we break this down, there are three things to it. One is payments, right? So agentic payments. How do agents pay online and why is it needed? Next is the standard called X402. What does this standard bring, which is new? And then the last thing is like, what is the privacy concept behind this, right? So I just took some notes. I can start with this, or is there anything else that you would want to talk about? Because this idea is like very vague that they have given, but we can, I just put up some stuff so we can discuss this first and then we can go to the idea.
So,
Yeah.
buddy, before that, maybe I'll just quickly tell you about Stellar as well, because this is probably like the first time you must be hearing about it, considering you're not from a blockchain or tech background at all. So, Stellar is one of the layer one blockchains, and one of the reasons why, so it is also an all-purpose layer blockchain, which means you can ideally build any kind of products on Stellar as well, just like let's say Ethereum or Aptos or Near, like any of the other Elvath or Solana. But Stellar is majorly known for its extremely low cost payment. So which means their gas is extremely low and their payment rails are very fast, which is why it is one of the best protocols to build anything related to payment. So when we are talking about payments, it can be retail payments, it can be institutional payments, it's basically like transactions that are happening from one party to the other, and that can be in any form. Now maybe we can also talk about what X402 itself is, so that you can understand that why we have potentially chosen this problem statement, that we
Uh,
can maybe.
I think before we go to X402, we should like discuss like what is the agentic payments and how is it different from currently the way payments happen. So there is a more structured approach to X402 that is introduced, which is the third
Yeah.
one here.
Nance, and if you have any questions now, you can just ask us like anything, some basic to
Yeah,
basic, so that anybody who's watching this video, even if they are a beginner, if they might also have the similar question as
question.
you,
Yeah.
it can be answered.
Okay. Yeah, sure. Done.
Yeah. So
I
this
think
like
for now, I think we can
broadly,
go ahead.
sorry, you have a question?
Nothing for now, but it can go ahead.
Okay, okay. Yeah, so broadly, like we are going to be discussing building something in the payment space. That is what is like the problem statement that we are choosing to do this weekend. And this one is like, so the first thing is to understand like how are current payment systems working, all of our payment systems like credit cards, UPI or whatever, and how is this agentic payments different? So I picked up some issues where agentic payments can actually are solving some significant problems. So agentic payments is nothing but we deploy AI agents which pay on our behalf, right? So here are some problems that it shared very quickly that agentic payments will solve. Like current system that we use is like we either use credit cards, we use subscriptions, or we use manual invoicing at scale to pay for payments. This is what we are doing. But here are some problems. Like if we want, for example, if we want something automated to happen, like we put up some, we are doing some investment, for example, and we want our bot to scan internet for some opportunities, right? It won't be able to scan unless we have given it some manual approval, right? So that is one of the problems. Let's say if we have an agent that we deploy right now, and we give it some level of authority that you can scan some of these opportunities and spend up to $10 per day. If I'm getting $50 worth of profit, like that, you can code inside your agent. So that way, your approval or your availability is not a blocker for the agent to proceed. So this is like one advantage, one main advantage, which is it removes human in the loop bottlenecks. So any other things like a claims processing, if you are processing an insurance claim, or anything like if you want an immediate insurance, let's say like you're stranded somewhere in the middle of nowhere and you need money to repair your car or something like that, right? So if you have an agent that can process this claims quite instantly, then you can avoid this like workflow that takes a really long time with the humans in the loop. So the intelligence is autonomous and the payments are not. So we give it some cap, we give it some conditions through which the payments happen. So this is one big problem that agentic payment solves. Then the second one is micro payments, which is when you're paying very small amount for services, the traditional card infrastructure can be quite bad. Because you have to basically, when you put in your card info, right, you have to you put in your card info to subscribe for, let's say, various services. What happens is you will have to put in your card info everywhere in all of these services that you want to access. But if you have an AI agent that needs to do micro payments, just use that service, pay per use. So let's say you want to use a Netflix service for a day. If there is a pay per use option, you can deploy an AI agent that can just pay for the service for that particular day and move on. Let's say, in this case, good, better example would be if you travel somewhere and you want to use a Netflix subscription in that country just for 7 days, right? So you don't have to put in your card info, get a subscription, etc. And similarly, other use cases like pay per use, per call, we call it like API calls, per article that you want to read. So all of these pay per use kind of methodologies will involve micro payments. That is very small amount of payments, and for which you don't need to expose your card for a long time. So this is one thing that AI agents can do. It removes a machine or like billing relationship similar. You don't have to put in your card details to subscribe, create an account and all of that. It just does it for you at that moment, when, if and when required, kind of situation. And then last one is if second last one was actually the last one. If you use an AI agent to develop something, right? Then what you will do is you will, let's say, you will you will have to pay the payments at a certain period of within a certain period of time to avail those discounts or to avail those vouchers, opportunities, etc. In this case, you can set that up using an AI. So the example they gave is if you want to develop a travel itinerary, right? You give the budget to your AI agent and you tell the AI agent, I want flights booked for these many people within this budget. I want a 3-star, 4-star hotel with breakfast within this budget. Here is a budget, and these are the dates I'm traveling. These are the dates for my hotel. And you give the budget to AI. The moment it gets a good deal on that budget, it will book and move on for you. So you don't have to wait. So these are like some of the opportunities that you get or like AI agents can bring from a payment standpoint. Most of these are around like, obviously you can't give like a huge amount of money to the AI agents, but you can give significant amount with a lot of conditions attached. So it will do the job on your behalf without you being present. So the projected scale of this opportunity is like AI agentic commerce will mediate 3 to 5 trillion of global commerce by 2030 without us even knowing that agents are doing this on our behalf. So there is a huge opportunity space in this. Ayush and Srilakshmi, do you want to add anything to this agentic payments?
If you want, I can like summarize you with some examples.
Yeah.
So especially for Nandini, I guess Gyan and Lakshmi are like already aware of most of these concepts. So earlier, when we used to deal with software, we used to lay down all the steps that you have to do all these things, A, B, C, D, and it can execute it step by step. Now, what has changed in the last, say, 1-2 years is that there is this new AI agents, which are like automated in a sense that they can also figure out the steps itself. If you will tell that I want to execute this task, it can come up with like different scenarios. You can execute in these 3 ways. It can also come up with that you can use these tools. It can also come up with how to use it in what order. So it's like kind of like more intelligent, but the only bottleneck which is there to do something like that is payments. Even if it's very automated, at the end of the day it's still dependent on humans, because all our payment system is like either it's UPI or either it's like credit cards. All of it you need humans and OTP and all these things. So how to solve for that payment part for this new automated world? So that's where they come up with like, okay, we can solve it through these crypto wallets which have stable coins. So stable coins are like, it's like a wrapped version of US dollars or some other currency, and it's stable. So they can use it directly. They can open their own wallet first. They can directly access the stable coin. And now if they want to say access to some particular tool, they can pay on their own. So
So simply like how Gyan said, if you set a condition as in, it can pay up to $10 or $20 a day, it will process the transaction on its own instead of us being there to authorize the transactions regularly.
Correct.
Okay. Simply reduces the bottleneck that is already there in the payment gateways. Perfect. Yes.
But I feel like one thing that we should definitely notice is, especially in crypto, not just in crypto, but I feel like there's a lot of scam that keeps happening. And in crypto, though, especially if they're able to track your wallet, or if these hackers are able to witness of like some transactions, they can actually come in between, hack and take the money from your agentic wallet as well. So this privacy and encryption is something we should definitely have to look at. And even like, instead of also trying it on like larger sum of money, we should try first with micro payments to ensure end to end that privacy is not being disrupted.
There's other part to it as well with regard to privacy. Like in normally when we use a credit card or UPI, our transactions are private only. Like it's not exposed. But because all of this payments is happening on blockchain, now everybody can see what tools are you paying for, what your agent is doing, everything. So now you need these privacy tools so that we can hide those things from like normal users. And it's like very genuine use case which is already there, just we are recreating it on top of blockchain.
When it comes to privacy protection, I think it'll take a while for them to develop some privacy that can be levied on such payments, because when UPI also came out first, there were scams that were happening with UPI also. Then when people started using that in large scale, then again the privacy, when people started getting into the privacy part, now it is actually end-to-end secured. So I think that will also, the time will come when this will also be, encryption will also be there. It's a matter of few days or months until people start using it in mass, and the importance, they understand the importance of encryptions.
So,
Yeah.
but actually now itself in blockchain, there are certain protocols or certain services that do provide like or are
Encryption. Yeah.
private first.
Yeah.
We in our like this hackathon project, we have to see if there is a way that we can incorporate that at least in like a demo level,
Yeah.
before making it like large scale, obviously.
Yeah.
Like the company that I work with, Starknet, which is a blockchain, we are like privacy. We are providing like we are kind of going more like privacy first. So we are already providing privacy primitives that you can use to like hide your transactions on chain, but also in a compliant manner. So and there are other blockchains as well that are kind of coming up with this. But I'm not sure how much stellar a blockchain has that infrastructure for privacy. So that's probably why they are looking for us to suggest some ideas and build something on top of what they have, like, and add some privacy layer to it. Okay, I put this example, which is a difference between like a agentic payment and UPI auto pay mandate. But I think it is pretty clear now, so we can skip this, right?
Yeah.
Yeah.
Okay, I'll share this doc anyway if anyone wants to read through. So now the next thing is like we went through this like agentic payments, right? Next is this x402 standard and how this kind of make sure that what does it do? So x402 standard is actually, so whenever you pay online, right, on the web browser, we pay through this on HTTP service. I mean, this was how it used to happen before. So on the HTTP service, whenever we are paying, the HTTP service returns a code. So for every action that we perform on our web browser, like trying to open something, we use HTTP, right? So on HTTP, every time we do something, and now we use HTTPS, every time we do something, there is a code associated with it that says that this particular action is happening or something, right? So 402 used to be the code associated with payments. So if we are performing an action, so anything that we order, whether we are paying for an Amazon order, whether we are paying for some Nykaa order or whatever, whenever we used to click on the pay thing, right, there is a 402 code returned to us that tells us that this particular action on the web browser is associated with a payment. That is, to proceed with this action, we need to pay. Then only this action will be completed. So this HTTP 402 was a status code that is associated with this called payment required, right? Now they have brought this back in the form of X402, which is a kind of similar replicating standard of HTTP 402. But this X402 standard is specifically designed for agents. So normal 402 code on HTTP is for humans. So they know that there is a manual intervention that is happening on a normal HTTP 4.0 code. But HTTP X40 code is specifically designed for agents. That means there are some add-on caveats to original 402. What those add-on caveats are, we don't have to worry about. But the idea for this is like agents can send and receive instant autonomous stablecoin payment. So stablecoin, as Ayush mentioned, one of the examples is USDC, which is a wrapped version, kind of wrapper coin of US dollars. So USDC value will always be one-on-one pegged with US dollars. That's why it's called stablecoin. The value remains stable. It remains stable with respect to USD. So in this, using this X402 code or using this X402 infrastructure, agents can pay by themselves using stable coins such as USDC directly over HTTP. That means any service that is hosted on like HTTP, agents can pay for that service, removing the need for subscription walls, redirects, and custom integrations. So how this happens very simply is when we are integrating an agent with a service, they will send an HTTP request for something, right? That agents want to buy something online. So the server will respond with HTTP 402 plus the payment details. That is, how do you pay for this particular resource? How much amount should you pay? What is the wallet address to which you should pay? And what is the currency that this accepts? And then agent sees all of that. Agent is already authorized by us, right? To pay some amount from our wallet. So agent pays on chain, that is on the blockchain, in the stable coin for according to this requirement. And once it pays, it gets a payment receipt and it will resubmit the same request over HTTP server with this payment receipt, and then server fulfills the request. So whatever product service agent was looking for, this is the step that it takes to make this payment over x402, which is the standard. And all of this happens within a single automated exchange. So there aren't multiple things that are all of this for us as a for us as a user. When we are looking at this, when the agent is doing it in front of us, it just seems like one single automated exchange. And the timing for this is sub 2 seconds. And all the transaction cost is approximately whatever this much. So even for the agent to actually do the transaction, we need to pay, right? Because we are paying for the compute cost of the agent. So this is basically the x402 standard in a simple way. That is, it allows agents to pay over web, over HTTP service autonomously. And it allows it to pay in cryptocurrency. So that is the x402 standard. So again, there are like these problems that we already discussed. So when it actually happened, current methodology without x402 is that you have to store the credentials somewhere. You have to store the OAuth, which is the authorization flows and everything. And humans have to set up the billing subscription. There's sometimes multi-step checkout UX and all of that. Whereas with the introduction of x402, we don't need any pre-registration. It's pay per use. Whenever you need the service, you pay for it. The settlement time is very less and the fee is also extremely low. It's not even as high as card fees. And it is on chain, so it is on the blockchain. And then the code is like very less, etc. So this is like x402 now is gaining a lot of traction. Even Google's agent-to-agent protocol, A2A protocol that they introduced, now incorporates x402 as an add-on addition. And yeah, basically it helps us, it treats this payments as a HTTP primitive rather than a human workflow. So this is where the x402 kind of comes into picture. If others want to add something, please feel free. And once this is done, we can go to like, what is the current problem with x402 standard plus agentic payments and how we can bring in like privacy into the picture.
No, I think you've covered most of it, or rather all of it. I don't know if it's relevant, but like this X402's research and everything was brought about by Coinbase only, and
Yeah,
it's only
Coinbase
then
is out
there
there.
are other layer ones who have sort of now started adopting it too and have their own versions of X402. So here we'll be sort of exploring this on Stellar itself, because Stellar's, like I said, major USP is that they are a finance first chain, DeFi first chain. So we will, like in our project, we'll be exploring how are we going to be integrating x402 on Stellar itself.
Okay, so now, okay, so this is basically, we just discussed this like basic stuff. So everyone's familiar and everyone's on the same page. Now, the way we generally work on like these kind of build that we are doing is that we will take the problem statement and we give it to our AI agent. So it can be anything, whatever agent you have. Like I gave it to my Claude, but you can also use ChatGPT, for example. So you take the AI, this problem statement, like here, right? And you say like to ChatGPT or whoever, hey, I'm looking to participate in this hackathon. And we just give the prompt to it. and looking for problem statements with this idea, inspiration in mind. So I'm going to provide this to it. And I have created this one. Let's say I can give it this link. I don't know if it can read or not. You have to check, some can read and some can't. And then I also actually found out this article. Oh, we have 10 more minutes, which is privacy pools on Stellar. So I didn't read through the article, but I downloaded the MD file for it. There is some information associated with privacy pools on Stellar in the MD file I'm attaching.
So, but if you're using Claude, no, you can just go to Claude Code
Yeah, you
and
go to Claude Code and you can give a similar prompt. So a lot of it
Okay.
is depending on like how good your prompt is, but you can always keep refining it, right? So from here, we'll get some idea context as to what are some different ideas. So it's giving us 10 strong problem statements, right? This is one. Now there is one that I was sharing the screen, which I also picked from Claude, which is ideas to build. So Claude has given us 3 ideas, and now ChatGPT is also giving us few ideas. So between these together, we can pick one idea and work on it. So in
Okay.
today's call, let's just finalize the idea. I mean, in this call, and then we can have another one in which once we finalize the idea, we will ask the agent only to expand on the idea, and we ask the agent only to build for us. So that's the whole point. So do you want to start with this or this Claude one?
पहले वो Claude वाला देखते हैं
हाँ,
quickly.
इसमें 3 है. Okay. So, okay. So the problem, as Ayush already mentioned, is that x402 payments are fully transparent on chain. That means anyone can see what your agents paid for, how much they paid for, which services are they accessing, right? So all of these, which agent paid which API, when and how much. So there is leakage of information, right? Whereas if we bring in something called as privacy pools, it will give us compliance preserving anonymity. That means we are anonymous, but we are compliant as well. That is, let's say if a finance entity comes and it says that I want to know this particular transaction was done by who, it is possible to reveal some of that information to them. That is only the compliance part of it. But other than certain sanctioned entities, no one else will have access to this data. So that is the anonymity part of it. So this compliance preserving anonymity is the one that is picking up. So far, there was just anonymity, not compliance preserving. That means no one can see. And that is a problem because you can then utilize these payments for any bad things. Okay, so the ideas that it is giving us is private x402 payment relay. That is, users pre-fund a privacy pool contract on Stellar. An operator or relayer holds a hot wallet that pays x402 API requests on behalf of the agents. The relayer batches withdrawals from the pool periodically to refill its wallet. Link between which agent made which API call and which deposit funded is broken. Okay. So this is a very straightforward one. As a user, I will deposit some money. Then there is a hot wallet. Hot wallet means like a wallet that is created on my behalf. It is not directly my wallet. So I will deposit into the privacy pool. And then there is a hot wallet that is there. And it pays for the APIs. And operator will batch the withdrawals from the pool. That's it. Like it's a bit of a little bit of a infrastructure play. Like it's just like a tech thing. But in this case, when you come to the payment trail, then you only show this operator's address. So there is an operator entity that we are building basically. Instead of us instead of showcasing that we are making the payment, there is an operator on our behalf which is making the payment, which creates the anonymity in this case. So this is like a little bit straightforward. Nothing too innovative, but doable. Should I go to the next one?
Yeah.
Okay. So second one is, okay. So these ASP, I'll show you, 1 second. There is, okay. So there is, this privacy pools is it's a bit more complex. Maybe we can just do another session on this. But within the privacy pool, there is something called as association set providers. So these are called ASPs that will define inclusion criteria intended to help mitigate illicit use. So this is because people want to use privacy pools for illicit use, right? For paying for financing terrorism, for example, right? Or for paying for black money. So to make these privacy pools compliant, there will be something called as association set providers, right? It could be as simple as a group of people, or it could be as simple as a piece of code that defines who should be included in the privacy pools, right? So that it makes the privacy pools more compliant. So how these rules are defined, all of that will be like by this association set providers or ASPs, right? They enable participants to selectively associate with sets of other participants who meet their chosen compliance standard. So if I am participating in this privacy pool and I want to send money or something, I don't want to deal with people who are using this pool for illicit use. So this ASPs will enable me to selectively associate with sets of other participants who meet their chosen compliance standards. So this ASPs is largely for like compliance. So here one of the use cases that they've given is that ASP gated x402 marketplace, which is x402 servers currently have no way to know if the paying agent is compliant. They just get paid, and you can flip this. So we build a middleware that before fulfilling a request requires not just a payment, but a ZK inclusion proof from a recognized ASP. So the ASP says that this agent's funding source actually passed KYC AML screening. That is, this person, the human behind the funding source, is actually a legit human. And once this proof is given to this, then only it goes ahead and makes the payment. So here, this is a privacy preserving compliance layer for x402. This is interesting, actually.
Yeah, actually, yeah.
Yeah, because before paying, like it is getting to know that the source behind the one who authorized this payment is actually like legit, right? So this can be one option that we can build. The other option that it has given is agent identity wallet with spending policies. So this is the problem that Sri Lakshmi was saying, that today an agent either uses your personal wallet or a shared hot wallet, which is the shared hot wallet is like this operator, building an operator. Yeah. So what it is saying is we can build a contract that acts as an agent's wallet with configurable spending policies. That is how much maximum per call it can spend, what are the allowed domains it can access, what is the daily spending cap, etc. And the wallet itself is funded via the privacy pool. So the funding source is anonymous. And the contract enforces policies on chain that the agent can only spend within bounds that we are setting it to. And spending receipts are published as, okay, this you don't have to worry about it, some technical stuff. So once the spending receipts are published, double spend is not possible. Double spend means spending the same money again is not possible. So this is also interesting. And I think a problem that a lot of people generally face when they are wanting to pay with agents, which is either they use your personal wallet or a shared hot wallet. But this is like we are creating a new wallet on its own. So how will that look like? I don't know. That might be a blocker again. I'm not sure. We have to go deeper into this idea. So these are 3 ideas that right now Claude has shared. Should we move on to the ChatGPT ideas, or should
I
we?
think we also have less than a minute. Maybe we should just finalize on one because all three are good ones. We can just quickly vote and see which ones we like. Or if you all want to see more, let me know.
Let me share this doc. Buddy, what's your? I have your this. Is this
Yes,
working?
yes. Send it to me.
Okay, I've shared this doc with you as well.
See, I personally feel like the third one is bit more better considering one is retail friendly. We have faced these issues, so like the adoption of it is going to be faster and easier. With the second one, I'm a little confused on the whole compliance side myself. Who is going to give these compliant rules?
That is only those ASPs. So if Stellar already has ASPs, so that is like that article that they have published now, which is their privacy pool design, which is already having ASPs. So if they already have ASPs, then we can use them. But if they don't have, then it's a problem.
And we are currently discussing between the second and the third one.
Yeah. Actually, do you guys want to go through the ChatGPT ideas quickly? So you
Yeah,
have.
let's go.
Yeah,
Okay.
we can.
1 minute.
Okay. So first is private AI agent payments. AI agents making x402. Okay, this is a standard problem. Private payments pool for AI agents. Agents pre-fund privacy. This is that operator one, same idea. Operator settles to service provider. So they don't know whether it is us. It is just some operator settling on our behalf. Okay, so this is the same one as first one. Then private subscription payments. So recurring payments expose user behavior, subscription providers, payment frequency. So it's saying just for subscription payments, we can have a separate privacy pool.
Okay.
Do you know how privacy pools work? Like, does everyone know how privacy pools work? Do you want me to
Not
pull a quick
high level.
privacy pool architecture?
Privacypools.com.
Yeah, that is. So, okay. This is a bit much, I think. No. Okay, so the simple logic behind privacy pools is in privacy pools, you deposit money, okay, into this pool. And and then there is like there is something that happens. I mean there is like the way that there is a contract, there is a privacy pool contract that takes and like creates a, depending on how the privacy pools work and all of that, they create a proof that you deposit X amount of money. And when you withdraw this money, right? So you can when you withdraw this money, you can withdraw it from some other address. So let's say if you withdraw it, you deposit money over here from some address, right? So for Nandini, context is in blockchain payments happens from an address to an address, right? So your identity on chain is defined by an address, and the address is generally a hexadecimal value which starts with 0x. So it will be 0x1234 something, right? And so when you're sending money on chain, you're sending from one address, which is 0x blah blah blah, to another address 0x blah blah blah. So in the privacy pools, what happens is how the way privacy pools work is you deposit through one address, but when you withdraw through another address. So there is no correlation between the address that deposited the money to the address that withdrew the money.
Withdrew the money.
Yeah. So the way it works is like if you so what happens is in general there is when you deposit, say for example, one ETH, one ETH
Ethereum.
worth of one ETH worth of value inside the privacy pool, there will be some sort of mixer that will happen inside. Some mixing will happen, and that one ETH will be distributed to various, let's say for example, places or something. And when you withdraw, when you want to withdraw 0.2 ETH, for example, people won't be able to trace whether it came from the one ETH that you deposited because of this mixing that happens inside the pool, right?
Okay.
Very, very simple. It's a bit more of a complex process, but there is something that happens inside the pool when you try to withdraw some amount of money, which is 0.2 ETH. It won't be able to correlate that this 0.2 ETH came from the one ETH that you deposited. And
Okay.
for this to happen, there needs to be lot of deposits into the privacy pool. Then only the mixer makes sense. Let's say only 1% deposits in the privacy pool, then people can obviously trace, right? That if I am the only one in the privacy pool that deposited one ETH and I withdrew one ETH, then it's just me. There is no privacy for me. Or let's say there are two of us. I deposited one ETH, Ayush deposited two ETH. Now, when someone withdraws 2 ETH, it is obvious that it is Ayush because I deposited itself only 1 ETH, right?
Yeah.
So the point of privacy pools is to have as many people participating in this privacy pools as possible. And this set of people, the set that gets created is called as an anonymity set, right? We can do another session on privacy pool if there's interest, which is needed for this hackathon actually. So maybe tonight or something, we'll figure it out. But this anonymity set has to be as huge as possible for good, solid privacy to come through. Because that's how you can, when a lot of people are depositing and withdrawing. So one more example I'll show of privacy pools, which one popular privacy pools that is there, which is privacypools.com. So if you see all of these pools, right, there are lots of different pools with different funds. So if you see this pool has only $36 and it has only 23 deposits, right? Like right now it has, I guess, 1,895 or something, but it has only 23 deposits. And each deposit is like, they have shown the deposit and the withdrawal and all. Let's say if suppose 2.765 is the highest deposit, right, in this pool. When someone tries to withdraw 2.5, for example, they can trace that back to this person who deposited.
This person.
Yeah, because the number of people in this pool is like super less. So this pool actually does not offer that much privacy. Whereas if you see other pools, which let's say is this pool, the ETH pool, it has a total of 3,033 deposits, right? So even in this, someone who deposited 31 ETH, right? If someone tries to withdraw 30 ETH, and there are not enough people who have actually deposited more than 29 ETH, you can track them. So the privacy is compromised. But it is slowly getting built. That's why privacy pools are also a new concept, fairly new. There was a popular thing called Tornado Cash that was doing privacy pools, but it was non-compliant. So here the compliance matters because apart from the person who is withdrawing, of course, they know what is the amount they deposited and withdrew. Apart from that, some compliant agency should be able to verify that alleged person is taking part in the privacy pool. That's why this compliant privacy pools are becoming more and more important. And that's why I said one of the problem statements we could pick is the compliance one. But we can figure out. So this is like how, just in general, this is how privacy pools work. Now for our problem statement, what are the things? So this is like what it is saying, only for subscription models, create a privacy pool. So like this, right? So we create same as how that privacy pool looks, but only for subscription. I feel this won't work because that, again, how many people use agents for subscription, we don't know. And if it is not large enough, the privacy is already compromised. because the pool will not get that many people in and out. So you can easily map. So that is like,
Crazy. Yeah.
yeah. So then this is privacy preserving agent marketplace. I think this is similar to that second idea, right?
Yeah.
X402 idea. So deposit to pool, purchase services privately, facilitator batches. Okay, enterprise agent payment router. Companies running agents leak internal workflows, vendors automation patterns. Solution is, it's just giving solution as privacy pool for a separate thing. That's it. Like enterprise subscription, something. Okay, this is private data payment pool, data marketplace. I think it is also similar. Instead of paying for subscriptions, if you are paying only for data on online, then you use this private pool. So separate privacy pool for that. Developer API privacy pool. This all its ideas like that. Agent to agent payments. This is interesting, where agent A wants to pay to agent B, but it is in a fully private way. So this could be something interesting.
But I think this is similar to the third problem statement that Claude has given.
No, that is not agent to agent. That is user allowing an agent to make the payments on their behalf.
On the behalf.
So that is like creating a wallet just for agent to access. But this is
But how many agents do you think will use this from one agent to another?
this one agent to another is now becoming popular after Google released their Google A2A payment. This one, but
Module.
it depends on your problem statement. Like if you are building complex stuff, right, you will be deploying multiple agents who are talking to each other. But I don't know how many will actually be paying to each other. So that is a use that we have to see. But definitely every good complex problem statement will have multiple agents that we are deploying, which are talking to each other or something. Then private micro payment infrastructure. So this is the same. It is just saying privacy pool for every separate problem statement. That's it. Compliance friendly. This is that number 2, ASP concept. The famous number 2 over there. And private Stripe MPP. I don't know what is MPP. Something related to Stripe. Oh, MPP.
Multi-party settlement.
Multi-party settlement. So users deposit, merchants withdraw privately, and operator batches settlements. Okay. So yeah, it is kind of similar problem statements to Claude, but yeah, here it is just asking to make more privacy pools. Kind of. This is also actually interesting. That if right, and if we have to pay, agents have to pay to merchants on our behalf using Stripe, then users deposit, merchants withdraw privately. So this is privacy for merchant. I think so.
But if it's via Stripe, then I don't know how will they be using Stellar's payment rails.
Maybe Stellar can accommodate something on Stripe.
I feel we should like look at some of the stuff which is already there in the market to get the sense that what is already say very common and what is not there.
See, this privacy pool stuff will not be there because most of this privacy pool stuff is very, very new. So for sure, there are no privacy pools. But agents paying using X402 will be there for sure. Because that is just agents paying through browser, right? Moment X402 came, that would be activated for sure. And I think Razorpay also has that, agents paying with X402. We can check.
I think we should go with the compliance one only then. I'm just not too sure how it's going to work out, but maybe while like the whole compliance part, but maybe when we build it.
Or we can also do this agent identity wallet. That's also not a bad idea.
Which is the agent to agent.
Third idea, yeah.
This is
That is not agent to agent. It's third idea and Claude.
yeah.
Yeah, that I feel like is a lot more retail first, like user friendly. Because this is a problem that like is faced by a lot of users. But this compliance will be something new to explore for us also.
Yeah, compliance. Yeah, the only catch in compliance is if this ASP already exists, because only the ASP can only give us the certificate. So we can't create an ASP that will give a certificate. That is another hackathon project by itself.
Yeah.
Oh, then maybe we should go with the third one only.
But Claude says go with idea one as the core. But I think many people will be building idea one. Everyone will be building idea one. I feel. I don't know if they'll be able to build it successfully. But I feel.
Yeah, let's try idea 3 then.
And it was
I'm
saying
down
and
for idea
build
3
on a
too.
simplified version of idea 2 as a stretch goal. It directly maps to the problem statement, pre-funding operator management segment. Seller privacy pool code, article is already prototype. Demos visibly compelling. But asking us to build an operator layer. Okay, this is for idea one. Idea two. Okay.
Or we can think about this for a while and then
Yeah, I've shared this doc.
come back.
Let's take some time. Maybe we can.
We can also
Okay.
check if there is an ASP that gives the
Yeah.
KYC screening.
Yeah, we need to check that actually. Because they have given the article, but I'm not sure. We have to
If there's
check
any
the
active ASP.
Yeah.
Yeah. If there is any, then we can make use of that for this.
Yeah. But who will use this also we need to see. This is a privacy preserving compliance layer. Directly using the ASP concept from Sarah article. Premium API providers could require this. So there's not like 100% guarantee that someone will use this.
Yeah, I'm telling you, let's go with the third one because anyway, we only have 2 days to build it. 13th is the submission. Let's go with the third one. And what I feel like we should do, like we've done, is that Gyan, you tell there are 4 people building it, give role segregation so that we can start building on our own.
Okay. Okay. So then I'll stop the recording.